Hello student, today we are doing lecture number 12 of a chapter solution, and what we are going to study today is types of solution. Right, now when I say types of solution, I am talking about ideal solution, and non-ideal solution. I'm talking about ideal solution and non-ideal solution, right? Non-ideal solution is further divided into solution showing positive deviation from ideal behavior and solution showing negative deviation from ideal behavior, right? But that we'll study later part of the lecture. First we'll understand what is ideal solution. पहले ideal solution क्या होता है वो समझते हैं अच्छे से, right? Now in last lecture we have studied, last lecture हमने Raoult's law पढ़ा था, right? और उसमें Raoult's law दो टाइप का है, एक है Raoult's law we call as Raoult's law 1 and Raoult's law 2, right? Now when I say Raoult's law 1, it was when the solute added was non-volatile, right? And the formula we derived over there was PA. PA क्या होता है? PA is a partial pressure, right? Partial pressure is equal to P naught A into mole fraction of A. अब ये P naught A, what is this P naught A student? P naught A क्या है? P naught A है a vapor pressure of a pure solution. PA is a partial pressure of a solution. And what is this XA? This is mole fraction of A. You remember? Alright. Okay. Now I'm talking about ideal solution. Right now I am talking about ideal solution. Non-ideal solution की हम अभी बात नहीं कर रहे हैं. We're not talking about non-ideal solution. So I'm going to cancel this. Right? Okay. So in ideal solution, when I call a solution to be ideal solution, right? And this formula is derived when the solute added is non-volatile. When the solute added is non-volatile, तो वो टाइम पे ये फॉर्मूला डिराइव हमने किया था लास्ट लेक्चर में, right? Now student, for a solution to be ideal, right, PA, that is partial pressure of A, should be equal to P naught A XA. ये क्वांटिटी और ये क्वांटिटी इक्वल होने चाहिए, राइट? तो सबसे पहले तो ये समझना है, वी हैव टू अंडरस्टैंड कि ये क्वांटिटी क्या है और ये क्वांटिटी क्या है. सी दिस इज ऑल्सो पार्शियल प्रेशर ऑफ ए. अगर मैं P naught A को और XA को मल्टीप्लाई करता हूँ तो मुझे जो वैल्यू मिलेगी वो P naught A की वैल्यू मिलेगी. बट ये वैल्यू जो है, राइट, दिस इज थियोरेटिकल. दिस इज व्हाट? थियोरेटिकल. And this one is experimental student. This one is experimental and this one is theoretical, right? Okay, तो ये experimental कैसे है? How it is experimental? That is what you have to understand. Okay, so for example, suppose I take a vessel, right, visible. In this vessel I have a solvent A, right? Solvent is what? A. In this I add solute which is B, right? Now this is non-volatile, right? So the B will present in the solution, but in the vapor phase only A will be present, right? ना देखो non-volatile solute की हम बात कर रहे हैं. मैंने what सपोज मैंने कोई सॉल्वेंट लिया, उसमें मैंने सल्यूट ऐड किया, राइट? बिकॉज सल्यूट क्या है? नॉन वोलेटाइल है, तो वो तो लिक्विड में ही रहेगा, उसके वेपर्स नहीं बनेंगे, राइट? तो वेपर्स किसके बनेंगे? सिर्फ ए के बनेंगे, राइट? ओके, बट दिस वेपर विल ऑब्वियसली नॉट बी इक्वल टू पी नॉट. वो प्योर वेपर के बराबर तो नहीं होगा ना, राइट? उससे थोड़ा कम होगा. ये हमने पढ़ा है कि उससे थोड़ा कम होगा, ठीक है? अच्छा, अब सोचो, I take some instrument and with the help of that instrument मैं इसका वेपर प्रेशर फाइंड कर लेता हूँ, कैसे? जैसे फॉर एग्जांपल मोनोमीटर, बैरोमीटर, मैंने कुछ अप्लाई किया, मोनोमीटर बैरोमीटर कुछ किया और मैंने फाइंड कर लिया इसका, इस सॉल्यूशन में जो वेपर्स है उसका प्रेशर, राइट? फॉर टाइम बिंग लेट्स अज्यूम, सपोज ये वैल्यू कुछ आया 30 एटमॉस्फेयर और mm of Hg व्हाटसोएवर, कौन सा? एक्सपेरिमेंट से 30 आया, ठीक है। और फिर मैंने पी नॉट ए वैल्यू, ये तो कांस्टेंट वैल्यू है किसकी? इस ए की, ये तो कांस्टेंट वैल्यू है, राइट? और क्या फ्रैक्शन में मैंने ए और बी ऐड किया है ये तो मुझे पता ही होगा, बिकॉज आई हैव एडेड दैट। यू आर गेटिंग दैट स्टूडेंट? तो मुझे मोल फ्रैक्शन ऑफ ए मैं कैलकुलेट कर सकता हूँ और फिर मैं पी नॉट ए से मैंने सपोज उसको मल्टीप्लाई किया, तो ये मैंने प्रैक्टिकल नहीं किया, ये मैंने थ्योरेटिकल किया, राइट? सो ये थ्योरेटिकल वैल्यू हो गई। अब ये थ्योरेटिकल वैल्यू, सपोज आंसर इसका भी आया 30, राइट? मतलब एक्सपेरिमेंटल और थ्योरेटिकल दोनों वैल्यू क्या आ गए? 30 आ गए, सेम आ गए, राइट? तो मैं तो बोलूंगा ये आइडियल सोल्यूशन है। हाँ, ऐसा भी हो सकता था ये वैल्यू सेम नहीं हो, राइट? इन केस व्हेन द वैल्यू ऑफ बोथ, दैट इज दिस इज पी ए, राइट, एंड दिस इज पी नॉट ए एक्स ए की वैल्यू, अगर दोनों की वैल्यू सेम नहीं है तो इन दैट केस द सॉल्यूशन will be what? Non-ideal solution, right student? But since we are studying ideal solution, I say both the values are same. Clear? Right. Similarly, in the same fashion, PB क्या होगा? P not B XB, right? यहाँ भी ये क्या है? ये प्रैक्टिकल, दिस वन इज एक्सपेरिमेंटल और प्रैक्टिकल, दिस वन इज थ्योरेटिकल, दोनों वैल्यू क्या है? सेम होगी, तो आइडियल सोल्यूशन होगा। या मैं ऐसे बोलूँ, अगर आइडियल सोल्यूशन है तो दोनों वैल्यू क्या होगा? सेम होगा, राइट? नाउ if I take now another case, I take A. Suppose this is a liquid A, right? Another liquid is B. This one is B, right? Both are volatile, both are liquid. ये भी liquid है, ये भी liquid है, right? ये भी volatile है और ये भी volatile है, right? I mix both the liquid, right? Now when I mix it, student, this we have studied in Raoult's law. Again, I'm repeating that. So in liquid state, A and B will be present, right? In vapors also, A and B will be present. A और B यहाँ भी होगा, लिक्विड में भी होगा और वेपर्स में भी होगा। क्यों वेपर्स में हुआ? क्योंकि दोनों वोलेटाइल हैं, राइट ना? तो दोनों वेपर्स में होंगे, राइट? नाउ इस पे कौन सा राउल्ट्स लॉ का फॉर्मूला कौन सा डिराइव किया था हमने? इफ यू रिमेंबर, वी हैव फाइंड PT, that is equal to P naught A XA plus P naught P XB, right? Remember? So this I can find again by practical. कैसे? जब मैं इसको मिक्स किया, इसके वेपर्स थे, मैंने कुछ इंस्ट्रूमेंट यूज किया और प्रैक्टिकली मैंने A और B के वेपर्स प्रेशर फाइंड कर लिया, राइट? और फिर ये मैंने थियोरेटिकली किया। Again, if the values are same, I will say this is ideal solution, right? So the first condition for a solution to be ideal, first condition for a solution to be ideal is they must follow Raoult's law. So they are following Raoult's law, right? Okay. So the first condition for a solution to be ideal is that they must follow Raoult's law. Second, and the very important one, listen. Now student, let's see over here first. A and A is there, right? When I say ये liquid A है, for instance I call this A, so there will be lots many of A present. I mean A is a molecule, so बहुत सारे A होंगे और A में bonding भी होगी, right? There will be force of attraction, there will be interaction between A and A. Clear student, right? In the same way, B और B में भी क्या होगा, there will be bonding, right? But when these two liquid are mixed, here I mixed them, so by mixing there will be formation of bond A and B, right? Initially ये bond यहाँ से break होगा, ये break होगा और फिर A और B के बीच में bond form होगा. Means there are three types of actual interaction. One interaction between A and A, other interaction is between B and B, and another interaction between A and B, right? Clear? Okay, now this is very important part, so listen carefully. Now second point for a solution to be ideal is the interaction between A and A, between B and B should be equal to what? AB. अगर इन सब में इंट्रैक्शन सेम है, ए का, बी का और ए बी का इंट्रैक्शन सबका इक्वल है, ओके, देन अ सॉल्यूशन कैन कॉल्ड एज आइडियल सॉल्यूशन, राइट? क्लियर? समझ में आया आपको? ओके, नाउ थर्ड पॉइंट, and this point will we understand better, okay, but let's see the third point. Third point is delta V mix. Mix means mixture. Delta V mix means change in the volume of a solution should be equal to 0, right? Now what's that? Let's understand. Okay, now student, this is very important. Suppose इसमें, राइट, ये जो मैंने लिक्विड लिया, द वॉल्यूम इज लेट्स से 10 ml. हाउ मच? 10 ml मैंने लिया. और ये जो लिक्विड है, यहाँ जो मैंने वॉल्यूम लिया, सपोज लिया मैंने 20, सो ये मैंने लिया 10 और ये मैंने लिया 20, बोथ इन ml, राइट? सो इफ आई मिक्स दिस, राइट, एज आई मिक्स्ड एंड एडेड ओवर हियर, राइट, दोनों को मैंने मिक्स करके इसमें ऐड कर लिया. Tell me what will be the total volume present here? Obviously we say sir 10 और 20 हमने ऐड किया है तो ये 30 ml होगा, right? And we are very sure about that. Okay, but student, this is not always true, right? Volume is not additive property. This is not always true. हर बार ऐसा नहीं होता. But अगर ऐसा है, okay, if this exists, so change in the volume क्या होगा? Change the volume will be 0 because हमने ऐड कितना किया? 30 ml. ये इनिशियल वॉल्यूम, सपोज दिस इज व्हाट? इनिशियल वॉल्यूम. फाइनल वॉल्यूम क्या है? 30 ml. सो इफ आई हैव टू फाइंड चेंज इन द वॉल्यूम, इज फाइनल माइनस इनिशियल, तो फाइनल इज 30, इनिशियल इज ऑल्सो 30, तो क्या आ गया? 0, राइट स्टूडेंट? ओके, सो व्हेन आई से डेल्टा वी मिक्स is equal to 0, right, then the solution is said to be ideal, right? But the question is, क्या ऐसे भी हो सकता है कि डेल्टा वी मिक्स 0 ना हो सकता है, right? Okay, and we understand over here. इससे समझते हैं स्टूडेंट, लेट्स अंडरस्टैंड. सी, ए और ए के बीच में इंट्रैक्शन है, बी और बी के बीच में इंट्रैक्शन है. सपोज आई से दीज इंट्रैक्शन इज नॉट इक्वल टू ए बी का इंट्रैक्शन. सपोज यहाँ इंट्रैक्शन ज्यादा है, फोर्स ऑफ अट्रैक्शन ज्यादा हुआ, तो ए के मॉलिक्यूल के बीच में कुछ डिस्टेंस था, राइट? बी और बी के में, और ए और बी के बीच में अगर अट्रैक्शन ज्यादा हुआ तो मॉलिक्यूल कम क्लोजर. सो इफ मॉलिक्यूल कम क्लोजर स्टूडेंट, व्हाट विल हैपन? वॉल्यूम विल डिक्रीज, वॉल्यूम कम हो जाएगा. एंड व्हेन द वॉल्यूम डिक्रीजेस, राइट, obviously the change in the volume will not be 0, right? For example, यहाँ 30 है और यहाँ मैंने 28 ले लिया फाइनल वॉल्यूम, so delta V value will not be equal to 0. और in the other way, suppose यहाँ अट्रैक्शन ज़्यादा था और यहाँ अट्रैक्शन कम हो गया तो वॉल्यूम बढ़ जाएगा. वॉल्यूम बढ़ जाएगा तो अगेन delta V mix will not be equal to 0, right? For a solution to be ideal, right, delta V mix should be equal to 0, and this can become 0 only when this condition is satisfied, right? I hope the second condition understood. Okay, now student, fourth condition, delta H mix, this must be also equal to 0. Now what is this delta H mix? Let's understand well. आपको पता होगा what is delta H. What is delta H, by the way? It is change in what? enthalpy, right? What is change in enthalpy? And we have studied this in 11th standard. If delta H की value is suppose negative, the process is called what? Exothermic, right? But if delta H value is positive, the process is called endothermic. Remember? याद आ रहा है आपको? एक्सोथर्मिक में क्या होता है? हीट इवॉल्व होती है, और एंडोथर्मिक में क्या होता है? हीट एब्जॉर्ब होती है, राइट? ओके, नाउ स्टूडेंट, let's understand this. Why delta H mix should be 0, or in what condition delta H mix will be equal to 0. Suppose A और A में एक इंटरेक्शन है, B और B में obviously एक इंटरेक्शन है, right? Okay. Similarly, A and B also have some interaction. Now, suppose I want to break this bond. तो ये बॉन्ड तोड़ने के लिए मुझे एनर्जी सप्लाई करना पड़ेगा और एनर्जी रिलीज होगी. टेल मी. Whenever we want to break a bond, energy need to be given. तो मैं एनर्जी सप्लाई करूंगा. जब मैं इसको सप्लाई करूंगा तो ये बॉन्ड यहां से ब्रेक होगा. जब ये बॉन्ड ब्रेक होगा, राइट, ऑब्वियसली आई गिव एनर्जी, डेल्टा एच की वैल्यू विल बी पॉजिटिव बिकॉज उसने एनर्जी एब्जॉर्ब किया. बी और बी में कभी अगर मैं बॉन्ड तोड़ूं, इफ आई ब्रेक अ बॉन्ड, आई हैव टू सप्लाई द एनर्जी. यहां भी मुझे एनर्जी देनी पड़ेगी, राइट? बट व्हेन ए एंड बी विल बी फॉर्म्ड, जब भी बॉन्ड बनता है एनर्जी रिलीज होती है स्टूडेंट, राइट? सो यहाँ बॉन्ड बन रहा है मतलब एनर्जी रिलीज होगी. सो दिस वैल्यू विल बी पॉजिटिव एंड दिस वैल्यू विल बी नेगेटिव, राइट? ओके, सपोज दिस इज, आई से सपोज दिस इज +50 एंड दिस इज -50, राइट? बिकॉज इंटरेक्शन इज सेम. तो अगर मुझे इसको तोड़ने के लिए, लेट्स टेक एग्जांपल, इसको तोड़ने के लिए मुझे 20 जूल की एनर्जी लगी ए और ए को. सपोज बी को तोड़ने के लिए, राइट, बिकॉज आई एम सेइंग इंट्रैक्शंस आर इक्वल, मैंने बोला कि इसमें भी सपोज 20 जूल लगा, राइट? बट जब ए और बी फॉर्म हुआ, राइट, और मे बी इट इज 13, नॉट नेसेसरी 20, नॉट नेसेसरी सेम, बट दिस एंड दिस शुड बी सेम, राइट? सपोज 20 40 लगा, राइट? और यहां जो एनर्जी रिलीज हुई वो कितनी हुई? दैट इज 40 जूल. सो व्हाट इज चेंज? This is +40, this is -40, right? If I have to find difference between them, the difference between them will be 0, right? Okay, so that's why delta H mix should be equal to 0 for a solution to be ideal, right student? Understood? Okay, that was 4th point. Next point, that is 5th. Delta S mix should also be it should be greater than, not equal student, it should be greater than 0, right? What is delta S? If you have studied the chapter thermodynamics, right, तो आपको पता होगा what is delta S. Delta S is change in entropy, and entropy is measured on randomness. ग्रेटर द रैंडमनेस अगर ज्यादा है तो एंट्रोपी ज्यादा होगा, राइट? और अगर डेल्टा एस की वैल्यू पॉजिटिव है, ओके, देन द सॉल्यूशन विल बी आइडियल, राइट? एंड एक्चुअली स्टूडेंट, आई एम टॉकिंग अबाउट डेल्टा एस, दैट इज चेंज एंट्रोपी एट अ वेरी superficial way, right? I will surely go in great depth in the chapter called thermodynamics, but for time being, understand delta X mix, delta S, actually it talks or gives information about randomness. And when we add these two liquids, number of molecule increases in this. Obviously, suppose I say I have 100 molecule, but when I add in this solution there will be 200 molecules. So when the molecules are more, right, randomness will be more. When the randomness will be more, obviously delta S will be greater, right? Okay, now next is delta G mix. Delta G is what? Again, this we are going to study in thermodynamics. For timing, understand delta G is called change in Gibbs free energy, and this should be always less than 0. ठीक है? तो सोल्यूशन को आइडियल होने के लिए डेल्टा एस मिक्स 0 से ज्यादा होना चाहिए, डेल्टा जी मिक्स 0 से कम होना चाहिए. एंड वेरी इंपॉर्टेंट पॉइंट, these two values, right? They're always equal whether the solution is ideal, non-ideal, whatsoever. तो इसमें कोई changes नहीं होगा whether solution ideal हो या non-ideal हो, right? या positive deviation दिखाए या negative deviation दिखाए, does not have any effect on that, right? So ये तो always same होगा, तो just remember this, right? But understand remaining topics, right? First one is it must follow Raoult's law at all condition. Interaction between AA, BB should be equal to interaction between A and B. Delta V mix should be equal to 0. Delta H mix also should be equal to 0. And the last one, delta S mix should be greater than 0, and this delta G mix, that is Gibbs free energy, should be less than 0. If all these conditions are satisfied, I will call solution as an ideal solution, right? Understood? Clear? Okay. Now student, we'll see the graph, and if you remember, the graph we have drawn for Raoult's law is somewhat similar to that, okay, for an ideal solution, and then we understand example also, right? Or let us first understand example, okay. Is it visible till here? Okay. So, okay, now let's understand example first. How can I, because in MCQs the question will come and they will give you some compounds, pair of compounds, and they will ask you, tell me कि कौन सा ideal solution है out of this 4 which is non-ideal or which is ideal solution. So how to identify that? Okay, now student, this we decide on the basis of 2 parameters, right? Parameter 1, molecular weight. They must have comparable molecular weight or molar mass. Secondly, polarity. The polarity must be equal or same, almost same. Example, suppose I say I have methyl alcohol CH3OH and I have ethyl alcohol C2H5OH, right? The polarity between them is same because they belong to same functional group, right? And the molar mass differs by only 1 carbon and 2 carbon, so by 14 units, right? So comparable molar mass, right? So we can say this is ideal solution, right? Or I have benzene C6H6 benzene, and I have toluene, right? What is toluene? Benzene and CH3, right? Comparable molar mass, they both are non-polar, right? And molar mass is also differ by 14 units, right? So these are the example, right? Or I let's say I have C2H5Cl C2H5Br, right? The polarity and the molecular weight are almost same, right? So in that case I can say this is ideal solution. This is how we identify, right? What is non-ideal solution? When we see, we'll understand कि non-ideal में क्या होता है और ideal में क्या होता है. We'll see the difference. I hope this much is clear. Now student, we have to draw the graph. As I told, we have to draw the graph. Now such graph we have already drawn, where we have drawn this in Raoult's second law, that is x-axis, y-axis, right? Here I take vapor pressure, student. Here I take mole fraction, right? You remember? Okay. And first I draw it like this. This represent what? Suppose volatile liquid, right? So this is PA, P naught A XA, right? This line represent this one, okay, and this value is what? P naught A, right? Okay, similarly I write here suppose I say this is P naught B, and what is PT? Remember student, PT is this value. This is what is PT, total pressure. Remember? Okay. Now this line is for PA, this is for PB, that is PB is equal to P naught B XB, and this is PT, that is PA plus PB, right? Okay, now so this is the graph. In ideal solution this all will be followed, right? Clear? Now let's see what is non-ideal solution, student. Let's see. Non-ideal solution. Now same way, in non-ideal solution it does not follow Raoult's law, right? It does not follow Raoult's law का मतलब here PA P naught A XA के equal नहीं होगा, PB will not be equal to P naught B XB, right? PT will not be equal P naught A XA P naught B XB, means ये सारे practical values जो है और ये जो theoretical values हैं, they will not be equal. If they are not equal, then and only then I can say this is non-ideal solution, right? Okay, now that's the first point. Second one is interaction between A and A, B and B. This is not equal to interaction between A and B. इसके interactions equal नहीं होंगे, right? After adding, interaction may be greater or less. Okay. Third, delta H. Sorry, we have written delta V mix first. Delta V mix first will not be equal to 0. This I've explained. हमने suppose 20 ml लिया, 30 ml लिया, total 50 ml होता है, but after adding जब मैंने उसको measure किया, it was not 50 ml. Okay, that is the case, right? तो मैं इसको कहूँगा non-ideal solution है, right student? Now, next point is fourth point. Delta H mix will also be not equal to 0, right? Heat evolved can be more, can be less, whatsoever, right? Delta H mix will not be equal to 0, then the solution is non-ideal. And two more points we have discussed. वो दोनों पॉइंट में कोई चेंजेस नहीं आएंगे, वो पॉइंट वैसे ही रहेंगे, ठीक है? क्या पॉइंट था? डेल्टा एस मैक्स will be always greater than 0, that is change in the what? Entropy, and change in Gibbs free energy delta J max will always be less than 0, student. So if all this is satisfied, right, I say the solution is what? Solution is non-ideal if these cases satisfied, right? Understood? Now the important is we have to understand example, right? But before going to that example and graph, we have to understand non-ideal solution is of two types, students. Okay, let's see. Non-ideal solution is of two types. Solution showing positive deviation. Solution showing positive deviation from Raoult's law. And second one, solution showing negative deviation from Raoult's law, right? So solution is two type, ideal, non-ideal. Non-ideal is again of two type, solution showing positive deviation from Raoult's law and solution showing negative deviation from Raoult's law, right? We'll understand each one in depth. Okay, now okay, first I divide the page into two parts, rather four part, because otherwise I forget till where I have to write. Okay, now student, first we'll see solution showing negative deviation from Raoult's law. Solution showing negative deviation from Raoult's law. We'll understand this first. Now, see, almost the conditions are same, right? But the most important condition is force of interaction, right, student? Now, in this case, what happened? Let's see. A and A interaction, B and B interaction, right? This interaction is found to be less than the interaction of A and B. Means यहाँ A और B के बीच में ज़्यादा strong force of attraction आ जाता है, तो molecules बहुत नज़दीक चले जाते हैं. This is what all happens, right, when it show negative deviation, right? So first point you understood. I'm talking about first what about the interactive forces. So interactive forces between A and B is greater than that of A and B of B, right? Clear? Okay. Now second, when I say it's a non-ideal solution, that means it does not follow Raoult's law. So I can say do not follow Raoult's law in any condition, right? Third, and that's important, delta V mix is less than 0. When I say less than 0, that means it is negative, so that's why negative deviation, right? Okay, now when I say negative deviation, it is less than 0, we have to understand how less than 0. Okay, let's understand, student. See, A और A में एक इंट्रैक्शन मतलब एक फोर्स ऑफ अट्रैक्शन है, B और B में भी फोर्स ऑफ अट्रैक्शन है, बट इसके कंपैरिजन में A और B में फोर्स ऑफ इंटरैक्शन या फोर्स ऑफ अट्रैक्शन ज़्यादा है. सो फोर्स ऑफ अट्रैक्शन ज़्यादा होने से क्या होगा? मॉलिक्यूल नज़दीक आ जाएंगे स्टूडेंट्स. When they will come closer, when two things come closer, volume will decrease. When they move away, volume increase, right? So the volume in the latter part will decrease. So delta V mix will be less than 0. कैसे? Let's understand. Suppose initial volume. I write here initial volume and final volume, right? Initial volume after adding, suppose I say 10, I added 10 and 20, so total become 30 ml, right? Okay, and final volume after adding, I was expecting कि final volume will be 30, but after adding, when I measured it with measuring cylinder से जब मैंने उसको measure किया तो I found that volume was 28 ml, right? So what will be delta V? Delta V will be V2 minus V1. This is initial, this is final. So that will be 28 minus 30. So answer will be what? Minus 2 ml, right? So delta V was less than 0. I hope this is clear, student. Right? Simple. Okay. What is next point? Delta H mix. Okay. This will also be less than 0. Negative में सब less होगा. अब let's understand this. How it is less than 0. Suppose A and A is interaction. I want to break this. 20 जूल लगा, right? B और B interaction, इसको break किया 30 जूल लगा. ए और बी जब फॉर्म हुआ तो एनर्जी वॉज रिलीज्ड. How much energy is released? Okay, suppose I say energy released here. Understand, interaction of A and B will be greater. मॉलिक्यूल्स में इंट्रैक्शन ज़्यादा है, ये इंट्रैक्शन कम है, मतलब मॉलिक्यूल ज़्यादा स्ट्रॉन्ग बॉन्ड बनाएंगे. जब ज़्यादा स्ट्रॉन्ग बॉन्ड बनाएंगे तो एनर्जी रिलीज विल बी मोर, राइट. सपोज एनर्जी रिलीज इज व्हाट 55. बिकॉज एनर्जी इज रिलीज आई विल राइट माइनस, because delta H value will be negative. So this is minus, this one is plus. So this become how much? 50 joule. And student, this become how much? Minus 55 joule. Difference will be minus 5 joule. So delta H mix will be less than 0. Right? Clear, student? Got that? Okay. Now, moving further, fifth and sixth point is almost always same. We don't require to revise every time. I'm just writing delta S max greater than 0, delta G max will less than 0. This is always true for all cases, right? Understood? Now student, we understand the graph, and that's important one. Okay, now in a graph, in the same way, I write like this. Suppose expected graph for this is like this. This one is expected. I'm drawing this with a dotted line because I was expecting this will be the graph, because Raoult's law यही बोलता है, ठीक है. This is for A, right? And for B, I am drawing like this. Okay, and the total, you know, this addition of this will be like this. Right, this is vapor pressure, this is mole fraction X. Okay, now we have understood it before also. Okay, this is expected, student. This one is expected, but when actually we found, right, the vapor pressure was not same, because we have understood what PA will not be equal to P naught AXA. I was expecting this, right? Theoretical ये है जो हमने ड्रॉ किया है, but practical में हमको मालूम है कि PA is what? Less. Right, because we do understand does not follow Raoult's law, matlab every Raoult's law will be less. Understand this point. Okay, if you want I write here. So this will be less. Similarly, PT will also be less than what? PA plus PB. Got that, student? So expecting was this, but real it was less. When I say less, the graph nature becomes somewhat less and it looks like this. Here also it becomes somewhat less and the graph look like this. Similarly here also. So what I can observe, expected was this which I have drawn with a blue and dotted line, and the originality or reality, the truthfulness lies in the red one. Clear? Right? Okay. So this, when the solution show negative deviation from Raoult's law. Now student, the important part, how we are going to identify, so that is more important. Okay, so let's understand this. Now example, we'll understand first example. First example, and the very famous example, is between chloroform CHCl3 and acetone CH3 C double bond O CH3. Right, this show what? Negative deviation from Raoult's law. Okay, now how to understand, how to identify. Okay, let's understand. Now when I say chloroform, student, chloroform can be written as CH, here Cl, 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 right? Now C double bond O CH3 CH3, this one is acetone. अच्छा tell me, ऑक्सीजन और कार्बन में ज्यादा इलेक्ट्रोनेगेटिव कौन है? Obviously oxygen, so it will pull the electron to itself. This will become partially negative and carbon become partially positive. Can you tell me in carbon and chlorine which is more electronegative? Obviously chlorine ज्यादा electronegative खींचेगा इलेक्ट्रॉन, तो जब ये इलेक्ट्रॉन अपने तरफ खींचेगा chlorine become partially negative and this carbon become partially right positive. Now the carbon is in need of electron, so it is going to pull the electron from this hydrogen, right? So this hydrogen will become positive. Understand? See, carbon का इलेक्ट्रॉन कौन खींच रहा है? क्लोरीन. तो कार्बन के इलेक्ट्रॉन की डेफिशिएंसी हो गई, तो कार्बन क्या करेगा? हाइड्रोजन के इलेक्ट्रॉन खींचेगा, राइट ना? तो जब ये हाइड्रोजन के इलेक्ट्रॉन खींचेगा तो हाइड्रोजन क्या होगा? उसमें डिफिशिएंसी आएगी इलेक्ट्रॉन की, सो इट विल बिकम पॉजिटिव एंड दिस नेगेटिव विल फॉर्म व्हाट? हाइड्रोजन बॉन्डिंग, राइट? So initially in first vessel there were chloroform, in second vessel there is acetone, because chloroform सब chloroform ही है तो उसमें तो हाइड्रोजन बॉन्डिंग नहीं होगी ना, ठीक है? और एसीटोन में भी हाइड्रोजन बॉन्डिंग नहीं है, बट आफ्टर दे आर एडेड इट रिजल्ट इन द फॉर्मेशन ऑफ हाइड्रोजन बॉन्डिंग, राइट स्टूडेंट? सो मतलब फोर्स ऑफ इंट्रैक्शन क्या हो गया? बढ़ गया, राइट? सो ए बी फोर्स ऑफ इंट्रैक्शन इंक्रीजेस. So when this force of interaction increases, right, we understand it will show negative behavior. Got that? ठीक है, force of interaction बढ़ेगा तो वॉल्यूम कम हो जाएगा, डेल्टा एच की वैल्यू में एनर्जी ज़्यादा रिलीज होगी, राइट? ओके, सो इट विल फॉलो दिस. नाउ इट इज नॉट नेसेसरी, ज़रूरी नहीं है ना हर बार एग्जाम में यही एग्जाम्पल है, ठीक है? सो वी हैव टू अंडरस्टैंड मोस्ट ऑफ द टाइम when we have compound containing oxygen or nitrogen, such like compounds, right? Or with suppose CH3X3, right? When we add compounds such as CHX3 and compound containing oxygen nitrogen like this, okay, it generally show negative deviation from Raoult's law. Right? Clear? Now moving to the next one, positive deviation solution showing positive deviation from Raoult's law. Okay, now same way, first point I write about interaction, AA interaction, BB interaction, right? This time this will be greater, right? Last time this was less than A and B, मतलब A और B में जो interaction होगा वो क्या होगा? कम होगा, right? And second point, we do understand it does not follow Raoult's law, right? So if I have to write what PA is equal, sorry, PA P naught A XA, right? In this case this will be greater, student. मतलब जो एक्सपेरिमेंटल वैल्यू ज़्यादा आएगी और जो हम थियरी से करेंगे मल्टीप्लाई करके आंसर निकालेंगे वो कम होगा, मतलब रियल वैल्यू ज़्यादा आएगा. एक्सपेक्टेड वैल्यू जो है, ठीक है, वो नहीं आएगी, उससे ज़्यादा आएगी. जैसे एक्सपेक्टेड वैल्यू जो हम लोग फॉर्मूले से कैलकुलेट करेंगे, राइट? ओके, नाउ थर्ड वन, सिमिलरली I write Raoult's law as same. PB will be greater than P naught A XA, or I can write PT will be greater than P naught A XA plus P naught B XB, right? I can write this. Now next one, let me arrange the page first. Okay, visible? Yes. Here it's visible, yes. Okay, student. Now third point and the important one, delta V mix should be greater than 0. How it will be greater than 0? Understand, A में इंट्रैक्शन, B में इंट्रैक्शन, A B में इंट्रैक्शन कम है तो मॉलिक्यूल्स दूर होंगे, मॉलिक्यूल्स अगर दूर होंगे तो वॉल्यूम क्या होगा? ज़्यादा होगा, तो डेल्टा V mix greater than 0, right? Similarly, delta H mix will also be greater than 0. Now again we can understand here. See, A में इंट्रैक्शन ज़्यादा है, सपोज 20 जूल लगा, B में मुझे 30 जूल लगा, टोटल 50 जूल लगे. बट A और B में जो जूल मुझे लगा वो 45 लगा, बिकॉज वीक बॉन्ड था, जल्दी टूट गया, थोड़ा एनर्जी देनी पड़ी, राइट ना. ओके, सो नेगेटिव वैल्यू इज -45, पॉजिटिव वैल्यू इज +50, सो द टोटल वैल्यू विल नेट वैल्यू विल बी व्हाट, पॉजिटिव. दैट मीन्स डेल्टा H max will be positive, right student? Okay, next point, both point are same, that is delta S max is what, greater than 0, delta G max will be less than 0. This point is going to be same, right? Let's understand the graph. Now same way, graph is similar. Here expected is this one, student, with a dotted line. Expected is with a dotted line, right? In totality, right? But when I say what will be the original, the original will be here, it shows what, positive deviation. So जो total है वो इससे ज़्यादा होगा, ये value भी इससे ज़्यादा होगी, and even this value will be greater, right? Here I take vapor pressure, here I take mole fraction, right student? Okay, this value will be what, P naught A, this will be what, P naught B. Here XA, if I write here, XA is 0, XA is 1, XB is 1, XB is 0. I hope you understood this, right? So this is a graph, clear, right? And talking about example, we have to take such example where we suppose in exam it comes and we do understand that initially there is the presence of hydrogen bonding. पहले hydrogen bonding है और बाद में hydrogen bonding क्या हुआ, ब्रेक हो जाए, कम हो जाए. जैसे एग्जाम्पल आई टेक वाटर में हाइड्रोजन बॉन्डिंग होती है, राइट? और उसका बॉन्ड और दूसरा जो लिक्विड है दैट इज बेंजीन C6H6, it do not contain hydrogen bonding, it do contain hydrogen bonding. When these are mixed with each other, the hydrogen bonding of water will decrease, right? So when this decreases, okay, so the bond will become weak and then it will show positive deviation like this, clear, right? We can take another example, that is ethyl alcohol and water, methyl alcohol and water, or benzene, right? C2H5OH, suppose this is ethyl alcohol, it do contain hydrogen bonding, I take benzene C6H6, right? So there can be such examples, right student? Okay, so for today we have completed ideal solution and non-ideal solution, right? In next lecture we'll see what is azeotropic mixture. For today we stop. Thank you.